That means it's a lie. Okay? Here is the calculus fiction for you. To encourage more participation from the seniors, starting today and for the rest of the semester, every time you answer a question correctly, you will earn 75 cents. Indeed. Every time that you answer a question correctly for the rest of this year, you earn 75 cents. Don't forget, the first thing out of my mouth was this is now calculus fiction. Yes, calculus fiction. You have 3 minutes to answer these first 4 statements that are all built on this calculus fiction. Go. F not here, Ron B not here. Okay. Calculus fiction. Do not expect I'm giving you my money. Catch him biting his nails. Exactly.
I don't know where I'm going.
But it says he just answered the question. It doesn't say he answered.
It's that much of a choice.
All right. Kimberly,
I think I'm overthinking it.
I don't know about all that.
I think he just wants to get the basics.
No, clearly doesn't
Okay,
calculus fiction, but still these are good questions, so I'm expecting there are like complete answers. There are units. The dollar sign counts as a unit. Ask Caroline.
calm down. Go get it, just go get it. Jose, did yours have your name in it? I'm right here.
Mariah. Noemi. Mariah. Keep going. Adriana. Here you go. Jose. Ortega. Okay, Christian. Abraham. Edgar. Sorry. Jonathan. Nora. These are meant to be very straightforward, make you feel good about yourself kind of questions. Giselle. And more Giselle. There you go. Okay, Mariah, here you go. Bunch of stuff for you. Noemi. Okay. Adriana. Jose. Okay, and these have to be Jose papers. Ortega. Here. Kimberly. Christian. Abraham. Nora. Martyr. First time I've done it all year. All right, let's pull it together. Statement number 1. If Fabricio answers 8 questions correctly, he will have accumulated. Another word for accumulated.
Acquired.
Earned, acquired, added up. He would have acquired how much?
$6.
$6, not $16. I don't have that kind of money. My kid has to go to college. Statement number 2. I've got a launder on my paper. Victoria enters the class with $3.50 in her wallet. She answers 6 questions correctly. How much does she leave the room with?
$8.
$8. Great. Caesar ends the class with $9.50 in his wallet. Assuming he answered correctly 7 questions, how much did he have at the start? $4.25. Janet entered the class with $4.25 in her wallet. She left the class with $14. How many questions did she answer correctly? 13. How many of you guys got all 4 of these correct? In this fictional world, you would have just earned $3 each. I'm broke already, and not quite enough to buy a box of cookies. Just want to make that clear. Now, when I did number 4, here's what I did. I set this up and I said that $4.25. I know that I get 75 cents every time I answer a question correctly, and then in the end that has to add up to $14, and when I solve that I get 13. Oh no, solved it that way. Who did solve it that way? 2 people solved it this way? What other way is there? A whole lot of folks came up with 13. Jennifer, what'd you do?
I subtracted $4.25.
Okay, you said $14, the final amount, minus the $4.25, the initial amount.
And I divided the answer by.
And then you divided by 0.75. How many of you guys did it that way? And we still get 13, it all works, right?
Yep.
Okay, I set it up this way, and I want you to just jot it down on your paper this way and label this a little bit. So I want to add on some vocabulary terms here. The $4.25, that's what's in her wallet in the beginning, but I want to call this the initial value. Right? This is what she had initially in her wallet. The $14, that is how much she leaves with. That's going to be her final value. The initial amount, the final amount, this part over here is the total change. Right, her initial amount plus her total change is going to give her the final value. Is this okay? Mm-hmm. Okay, good. Congratulations. You know the fundamental theorem of calculus. That's exactly what this is, except no one ever described it to you that way. Let me give you exactly what the fundamental theorem of calculus is. My flashcard crew. Everyone has some flashcards. The fundamental theorem of calculus should be the next flashcard that you're going to create. For those of you that are just like, but where do I look in the middle of a quiz? It would be up here. Except covered or turned around. Here's what the fundamental theorem of calculus says. If f of x is a differentiable function, it's been a while since we've used this word. Haven't used it all year yet. Differentiable function means derivative exists and continuous. So differentiable means continuous and derivative exists. So here's what the fundamental theorem of calculus says in a textbook. F is differentiable on this interval AB. The fundamental theorem of calculus says f of b equals f of a plus the integral from a to b of f prime of x dx. That probably doesn't make as much sense as these 4 fictional problems that we just looked at. But let's take a peek at this again. F is my function. A is the start of the interval. So f of a is what I'm going to call my initial value. B is the last value on the interval. F of b is going to be the final value. F prime, you guys know what that is. F prime is the derivative. Derivative is a rate of change. This tells you, F prime tells you how fast, we can turn that off if you don't mind, Christian, how fast the function changes. F prime is just a rate, how fast the function changes. The definite integral, we talked about this right before we left on that winter break. If f prime is how fast the function changes, then the definite integral represents If f
How
prime is how
much?
fast, the definite integral is
How much?
how much the function changes by. How much the function changes by. The fundamental theorem of calculus is just like these 4 fictional problems that we just talked about. The final value equals the initial value plus the total change. So say that with me. The fundamental theorem of calculus
Fundamental theorem of calculus
says the final value
says that the final value
equals the initial value
equals the initial value
plus the total change.
plus the total change.
Okay, one more time. Fundamental theorem of calculus says
The fundamental theorem of calculus says
final value
final value
equals initial value
equals initial value
plus the total change.
plus the total change.
Plus the total change. Okay, so let's go back to situation number 3. Jose ends the class with $9.50 in his wallet. Assuming he answered 7 questions correctly, how much did he have at the start of the class? The $9.50 represents,
The initial, no, final value.
right? Jose ends the class with $9.50 in his wallet. That has language of final, right? The final value. What's f prime in this situation? Jose ends the class with $9.50 in his wallet, assuming he correctly answered 7 questions. Is that the rate?
There's the expense.
That's kind of the expect. What's the rate?
0.77.
The 0.75 per question, the 75 cents per question. That's the rate. The final value is like, what does he walk out of the room with? How much does he have in his wallet?
950.
950. That's right. That's right. 950. All right. That was about as gangster as I'm gonna get. All right. Fundamental theorem of calculus. F of b equals f of a plus the integral from a to b of f prime of x dx. Now, depending on the textbook, or depending on if you go to Wikipedia or Wolfram Alpha, you might also see this one. And I want to make sure that you see it here first. The fundamental theorem of calculus is also sometimes written as the integral from a to b of f prime of x dx equals f of b minus f of a. Does anybody see that as being the same thing as what I wrote originally? Jasmine sees it as being the same thing. Looks like Abraham maybe sees it as being the same thing. Adriana, you see it as being the same thing. Abraham, convince me that those are actually the exact same thing.
That's because the function that we used on the left,
Yep.
you just subtract f of a from f of b, and then there you get the.
Is that okay to do that? Right, to just subtract it. So you're saying f of b minus f of a equals the total change? It's a lot like the folks that said, take that $14 at the end, subtract from it the $4.25 that I started with, and then do your division thing. This is the fundamental theorem of calculus. I think memorizing it is going to be easy enough. Memorizing it this way, memorizing it this way, it won't be a problem. I think what is going to be the problem is knowing when to use the fundamental theorem of calculus. So here's the thing that you look for. For those of you that are like looking for a checklist, here's the thing. The fundamental theorem of calculus has 3 parts. An initial value, a final value, and a change. As long as you have 2 of the 3, it's probably a fundamental theorem of calculus question. So let's look at an example. You guys are going to get plenty of practice today. And please do not let me forget that at 3:55 we need to go to that other place. The recreational area. All right. Resist the temptation to say that this problem must be a fundamental theorem of calculus question because the paper says fundamental theorem of calculus at the top. We're going to read this carefully. Martier, can you read this opening problem?
The figure to the left shows the graph of f prime where f prime.
Oh wait, so this is the graph of what?
F prime.
Okay, graph of f prime. Let's make sure you mark that up. Make sure you know what graph this is.
Where f prime is the derivative of f for -1 less than or equal to a.
Yep. Still less than or equal to, yeah.
With f, I'm 0 equals 1. The graph of f of, so there is it.
F prime.
Because it was 3 line segments, semi-circle. Find the values of f of 4 and f of negative 1. Show the work that leads to the answer.
Okay, so let's just focus on I want to find f of 4. F of 4 is the thing I want to find. Now you might already be thinking, of course it's a fundamental theorem of calculus question. This is only a fundamental theorem of calculus question if you have 2 of the 3 parts. And the 3 parts are an initial value, a final value, and the change. They told me earlier that f of 0 is equal to 1. F of 0 is my initial value. Have they told me how the function changes? I'm seeing a lot of like, not really sure. Adriana, you think you see that they told, where?
In the graph?
Right, because this is the graph of f prime. F prime is telling you how the function changes. It tells you how fast. For the fundamental theorem of calculus, we said it's f of b equals f of a plus the integral from a to b of f prime of x dx. I have an initial value, that's the f of 0. They told me f prime, but this is the part that I need. I need the final value. So my setup is going to look like this. I'm going to say that f of 4, my final value, well, how do I get the final? It's the initial value plus the total change. Final equals the initial plus how much the function changed from 0 to 4 of f prime of x dx. What's f of 0? F of 0 is 1. Now for the tricky part, how are you going to find the definite integral from 0 to 4 of f prime of x dx? Oh my gosh.
Just find the area of the graph.
Right, all you need to do is go find the area, right? Go find the area from 0 to 4 of f prime of x dx. If you know how to finish it off, finish it off. For those of you that aren't sure, we're going from 0 to 4. Let's see, how am I going to go from 0 to 4? Well, I see a triangle, I see a semicircle, and I see a triangle. That's good. Area of a triangle is going to be a half times my base has a width of 1 times my height, that's 2. Let's see. I know area of a circle is pi, radius squared. Uh-oh, I've only got half of a circle. So multiply that by a half. Plus this guy over here, a half times 1 times 1. The mistake I hope everybody can avoid. What about the negative?
The semicircle is going to be negative since it's under the graph.
Right, because it's not that it's under the graph, it's under the x-axis. So that has to be a negative value over here. So it should be 1 plus this value minus this value plus this value. Depending on the part of the test, if it's free response, stop, don't simplify. Well, let's assume it's multiple choice, let's clean this up. Half times 1 times 2, well, that's just 1, minus pi times 1 squared, that's pi. I've got pi over 2 plus a half. 1 plus 1 is 2 plus a half. I think if I do this correctly, 5 halves minus pi over 2, I could get a common denominator, and I could call it 5 minus pi over 2. And we'd be done. Giselle, you okay? Camera, okay? Fundamental theorem of calculus, we're okay? Okay, so I wanted f of 4, I knew f of 0, then I had to do the definite integral from my start to my end for f prime of x. See what you can do with f of negative 1. How am I going to find f of negative 1? I can think of at least 3 different approaches you could take. See what you can do. So I've seen some people that have set this up and said to find f of -1, if f of -1 is the final, then it's going to be your initial plus the integral from 0 to -1 of f prime of x dx. I'm curious, how many guys set it up this way? Martyr set it up this way, Abraham set it up this way, so some folks are setting it up this way. Does this fit the fundamental theorem of calculus? Final, initial, plus total change. Okay, so f of 0 is 1 plus, want to be careful here, I want to find the definite integral from 0 to -1 f prime of x dx. Christian, what's the mistake I want to make sure you guys avoid here?
Not select the from A to B.
So we're going from 0 to -1, right? Here's 0, here's -1. What's the mistake to avoid?
Let's not go from left to right.
Right, you're not going left to right, we're going right to left here. The area is easy enough to find. It's just going to be a half times 1 times 2, but I'm going to have to use the negative version because I'm going in the wrong direction. So my final answer should be that f of -1 is equal to 0. How many guys get 0? Okay, that is a way to set it up. Here's another way. Cynthia last period said, wait, I don't think that f of -1 is the final. What she said is f of -1 is the initial value. So what Cynthia did is she said, okay, if f of -1 is my initial, then what's the final value? F of 0 is the final value. She said final equals initial plus the total change. F of 0 you know is 1. F of -1 you don't know. What's the definite integral from -1 to 0? If I'm going to go from -1 to 0, the area over there is 1. Subtract 1 from both sides, you get that 0 is equal to f of -1. The end of the story is you've got some flexibility with what do you call initial and what do you call final. Where you have no flexibility, though, is if you're going to say f of -1 equals f of 0 plus, the lower limit is 0, the upper limit is -1. If you set it up this way, f of 0 equals f of -1, -1 is the lower limit, 0 is the upper limit. Okay, show me what you guys can do with the second one. Poorly calculator active. Trust your instincts. Trust the smarticle particles. Is it done charging, sir? Consider a function f such that f of 1 equals -4, f prime of x equals x times the cosine of x. Find the value of f of pi and f of -pi. F of pi, I've got an initial value, so plus the definite integral from 1 to pi of f prime of x. I am 95% convinced that if you can set up the fundamental theorem of calculus correctly, you get it from there. It's just knowing this new tool in the toolbox. Just quick show of hands, how many of you guys have it set up this way? F of pi equals f of 1 plus the integral from 1 to pi. Okay, we're in a good place. So, f of 1 we know is -4. How on earth are we going to find the definite integral from 1 to pi of x cosine of x dx?
We just, don't we go to our calculator?
Right, you can just go straight to the calculator, have the calculator do the heavy lifting here. And my advice, type this in exactly as you see it into the calculator. Make sure it is in there. Do this in one step, get one number, be done and move on to the next part. When you think you've got the right number, just call me on over. Not quite. So, f of pi is what you want, and that's the final value. This guy. Your limits of integration, the lower limit is 6.3 this one over here. 138 matches this guy. That's fine, though, because the initial plus the love it. Keep going. What'd you get? No.
So it's basically the same.
Marvin's just helping me get my 10,000 steps as soon as I walked away. Come on over. No. It's been a couple of weeks since some of you may have used your calculator. What mode are you in right now?
Make it fix.
Radian mode. Make sure you're in Radian mode. If when you turned on your calculator, that little black bar went across the screen, that was your calculator resetting itself because you went away for so long. You might even have to go back and reset it to English.
What your interval from negative pi to 1?
No, we're
Radius.
I did have it in
You
radius.
always have to be in Radian mode.
That's what I did.
It broke.
Wait, why did I get a different answer?
-4 plus the integral from, okay, wait, look at your
I
limits here.
charged it last night.
Oh, wait, you're on f of
It was on.
negative pi now?
I picked it up.
If all goes well, your answer should be -6.381. If you got that, go find f of negative pi. If you are not getting this -6.381, let me know before we move on.
Oh, it is because it's smaller. It's not.
Okay, and you get the same thing both ways? That's exactly what it is. All right, good, keep going. You got it. You got it. Okay. Good.
But why didn't I do this one? That one was negative pi.
To get f of negative pi, f of 1 plus the integral from 1 to negative pi, f prime of x dx. And your calculator does all the heavy lifting. For the, I think some of you, how many of you are maybe a little bit uncomfortable with this integral over here? There's something you don't like. Jasmine, what don't you like? You don't like pi, no. We love ourselves some pi. There's a problem here. There's a problem here. Daisy, what's the problem?
That says F prime.
That it says f prime? That's actually not the problem. It's a good thing that it says f prime. Jasmine.
Isn't it also from negative pi to 1?
Right, normally when we think about our limits of integration, we want to go from like left to right, not right to left. And so if you're like, oh, I know I need to switch it, is it okay to switch?
No.
He just did.
It is okay to switch, but there's a cost for switching those limits of integration. It doesn't go to positive.
You have to switch the initial.
You have to switch the sign.
Oh.
Right, if this
Oh.
was a positive value, now it has to become a negative value when you switch the limits of integration. But here's the good news though, in terms of your calculator takes that into account already. So you could just say it's -4 plus the integral from 1 to negative pi, and your calculator knows the rules. Or you say it's -4 minus the integral from negative pi to 1, and your calculator knows the rules. Either way, you're going to get -6.381 381 in both cases. And I hope everybody's okay. All right, let's push one more time. One more time. I want to do this application problem, but I want to change these values. Make all these negatives into positives. That's not actually what we would really do in the business, but we're going to. Take a moment, read this over. We're going to have a conversation in just a little bit. Does this one fit as a fundamental theorem of calculus question? I think I'm going to need to confess. All right, particles moving along the x-axis with velocity modeled by a differentiable function. Selected values of v of t are given in the table above. The initial position is given by x of 0 equals -4. Use a trapezoidal approximation with 5 subintervals to estimate the position at time t equals 32. So I'll take stuff from anybody. What do we know so far? What do we know so far in this problem? Anthony, what do you know? Okay, this guy over here, this x of 0 equals -4, represents what? That's the initial. So we have an initial value. That's good. Okay, what else do we know? Other things that you know for sure. Edgar, what else do you know?
Well, we were talking about that since it gives us the time in seconds,
Yep.
it also gives, the chart gives us velocity. Wouldn't that be the derivative? So wouldn't that be the change?
Ah, well done. Say that one more time. I want to make sure that everybody on film knows how brilliant you are.
Oh, it was Christian.
It was Christian. Okay, Christian, who is in AP Physics, and if you didn't know this, I would tell. Okay? Velocity, what's the thing about velocity that you need to know here?
It's the derivative of distance.
Of distance. Oh, so ugly, I can't believe you just said that. Velocity is the derivative of distance? Of position, maybe? There you go. Somebody go tell Tarek, right? You've got the initial value for the position. We've got how the position is changing. That's what velocity is. And so then the question is this a final value kind of question? I think so. It said estimate the position of the particle at time t equals 32. This is going to be the final value. So your setup is going to be that the position at time 32 equals the position at time 0 plus the integral from 0 to 32 of x prime of t dt. Like if you're just plugging into the fundamental theorem of calculus, final value equals initial value plus the total change. The initial value you were told is -4 plus, instead of saying the integral from 0 to 32 of x prime, that's really the integral from 0 to 32 of v of t. New problem. New problem. How the heck am I going to figure out the integral from 0 to 32 of v of t dt? I don't have a graph. I don't have an equation. Jasmine, what do you say?
Can you put these into the chart on the calculator?
You've got all of these values. I don't know that my calculator is going to necessarily be so helpful at this point. We were doing this and doing this really well before the winter break. Right? It might be helpful to like plot some points so that you can see it. But see if you can get the setup. Because they tell you exactly how you're supposed to approximate this. They say use what, 5 trapezoids?
Yes.
Okay. So 5 trapezoids. If you need to go off on the side and kind of plot the points and say, here's 0, 5, here's 5, 1, here's 13, 6. I'm just plotting some points. I'm not going to let my OCD take control. No, sir, not this time.
You control it.
Exactly. I have the OCD. It doesn't have me. Right, I want to go from 0 over to 32. I need 5 trapezoids. Well, here they are. 1, 2, 3, 4, 5 trapezoids. Area of a trapezoid, it's been a while, but that was always 1/2 base 1 plus base 2 times the height. For the first trapezoid, first base,
0.
careful.
Oh, I mean,
The bases, right, those are the parallel
Extra
sides.
zero.
It's like how tall. So how long is this first base? The first base is 5,
5.
right? So this is going to be 5 plus the second base. Oh, so awkward. 1.
Oh,
The height, how far apart are those? Right, that's the distance in the x values. That's going to be 5. That's the first trapezoid. Finish it off. We're not going to bother simplifying or doing any of that because we only have 3 minutes left. Right now, just get me the setup. What's the next one? 1/2, 1 plus 6 times, what is that, 8? Okay, plus 1/2, 6 plus 10, this time times 7. 1/2, 10 plus 2, multiply it by 2. 1/2 of 2 plus 3, this time multiply by 10. Please don't bother simplifying. This is not worth simplifying. What are the units?
Meter.
Yeah, go back and make sure you understand the question that I'm asking. The units have to be,
Meters.
we're talking about position, so this has to be
Meters.
meters. Okay?
Let's see.
Okay. So that's fundamental theorem of calculus. We're going to keep playing around with the fundamental theorem of calculus over the next few days. Tonight's homework is not nearly as bad as you might initially think when you first look at this. It's 4 word problems. The whole thing is calculator active. Almost all of these are fundamental theorem of calculus questions. Almost all, March here. Don't jump too quickly on this. I care greatly about your use of units. I care greatly about your setups and all the other things. Yep. Okay. So at this point, we're just going to end earlier than usual. I am not able to stay after school today. I thought I was going to be able to, and then I get an email that I'm not able to. Okay.